Other than CPU usage and memory usage, the next thing we need to look at is I/O. Remember, the CPU is much faster than random access memory usage, and both of those are much faster than the disk. The most important factor in determining not only I/O distribution but the general usage of I/O is the function of the database. A data warehouse does lots and lots of batch work and lots of reports and lots of large updates. Large queries, therefore it's going to be very heavily I/O. You don't need a lot of memory because stuff is read and written from disk. Large amounts, you cannot possibly have enough memory to shove the whole lot in memory, and that's always a bad idea even with an OLTP database. An OLTP database should have low I/O usage and preferably very high distribution. In other words, things split up all over the place. A data warehouse can benefit quite well from being distributed in that you can use things like partitioning to run things in parallel against multiple sets of data at the same time. Obviously, the available distribution methods are very important to take into account. For instance, where do you put the different Oracle database file types, such as indexes and tables? Obviously, relative to each other. Are things used at the same time? Are they read and written at the same time? Or both or either? The block size is obviously important. You can consider using multiple block sizes when you have a mixture of activity. A data warehouse typically works most efficiently with large operations using a very large block size, even as much as 16 or 32K. An OLTP database, by default in the Oracle installation software, uses an 8K block size. You can even use down to a 2K block size, depending on the size of transactions and the size of tables in terms of row numbers and column width. How many table rows do you want to fit on a single block?